Once upon a time, there was a brand new, exciting, attractive technology called industrial inkjet printing. And it was so brilliant because it removed the bad, evil, old technology we used for printing, where you cut a shape on something like a potato and you dabbed it down and you threw it away when you finished and the rest of it. And that's what I came across 22 years ago when I joined this industry. But we haven't penetrated the entire world, have we? And there's still room to go. So this is FuturePrint. I'm going to show you some slides about some things which are happening in the industry, some trends. A few pictures you won't have seen before, because I know I haven't seen them before in the industry. And we'll talk a little bit more about the next step in this story that we're all involved in. Everyone in this room, I believe, is involved in the industrial inkjet industry to some extent. Otherwise, why would you be here? So what happened in those 20-odd years is that there have been an awful lot of industrial inkjet machines made, and they're in the industry, and people have looked at them, and there is a migration across, but it's not as fast as it could be, and everyone's now looking at why is that, what else could we do to make this transition quicker and better. So the story I'm going to give is about how do we optimize what we're doing, what things are happening to make the optimization happen, the end result of which hopefully will be a faster and growth for everyone's company who's in this room, no matter which part of it you play. The whole industry should pick up and go a bit faster. And we play a little bit of a role in that, and I'll explain what that is as I go through the next 15 minutes. So, what I mean by inkjet printer optimization, obviously there's optimizing the components that go into it. We've heard stories about optimizing your inks, or optimizing the print heads, optimizing the way things are created. But in the end, inkjet printers reveal their problems when you use them. If you want to see a problem with a mechanism, make it print, because then you'll see the problem in the mechanism. And I was a mechanical engineer for some 15, 20 years before I joined the world of inkjet. And that was, the old technique we used to do. We used to either fire a laser at it and look at that, or you'd attach a pen to it and see how it wobbled on something and gave you a record of what was wrong. So inkjet printers reveal all of the tolerances that you've built up in your machine. And what we need to do is optimize that. So my strategic objective, if you like, in this story today, or a story we all have, really, is to try and get more value out of what we've already created or what we can create. And at this point, I think the artificial intelligence that my parents produced 56 years ago needs an optical upgrade. Here we go. Now, sorry about that. I can't. This didn't happen before COVID, so it must be an effect of that, I think. What we're looking for today is making an inkjet printer that can lead to better sales, it's better for the environment, it's better for everyone here. And the way we're going to do that is we're going to try and make it work longer. So in the first 4 years of its life or so, the accountants are going to write off its value. At the end of that, they're going to look back and go, what was the total cost of ownership? What went wrong? What broke? How much of the time did it actually be used? Now, the problem with an inkjet printer is if you don't use it, it's not worth very much. So it's got to have an uptime, it's got to stay working. And ideally you really want it to be able to work 24/7, don't you? And some industrial applications, the printers do. They actually work not 24/7, they work non-stop for many weeks. If you think of the ceramic tile industry, for example, okay, I know everyone talks about that, has some reasons why it's easier than others, but in one way it's really quite hard, and that it's actually burning $1,000 worth of gas every hour. So, and it will keep doing that even if the printer's not working, even if you're not producing anything. So you've got to keep it working. So, and that's just one extreme example, but there are plenty of other examples where we're looking at how long is it before you have to stop printing, clean the nozzles? How long is it before you have to give up cleaning the nozzles and take a print head out and replace it? How long would that activity take before you can go back to printing again? How reliable can you make it? So the tactical things, if you like, we're going to look at very quickly are what's going on at the moment in the area of correcting for missing nozzles, correcting for color banding that may appear, or optimizing it so that it's not there, so you can print more images on your machine, because that's the other problem. Sometimes these machines are so quick Okay, they're digital printing, so they're not as quick as conventional, but nonetheless, they'll get through the digital printing jobs pretty quickly, and you've got to keep it fed. And one of the challenges there is that some of the jobs you don't dare put on your inkjet printer because they would reveal the faults. So you have to do them without the non-inkjet. So the greater width or variety of images we can risk putting onto the inkjet machine, the more utilization you can have. We had a whole bunch of customers a few years ago put together machines, and they couldn't keep them fed because they could only use around half of the images that they wanted to print on it, and the other half they didn't dare because when they tried printing them inkjet, it revealed errors in them that made it difficult to sell the product. So it might sound a little bit perverse, but actually sometimes improving things like the color banding you might get, or the stitch banding, or the variations in the heads because of temperature or because of ink supply or whatever it is, because of the manufacturing tolerances of the components in the heads. Getting rid of that actually allows you to put more complicated, or less complicated very often, images onto the inkjet printer and still be able to sell the output. So that's the story that I'm going to talk about. What's my next slide? Oh yeah. I'm going to talk a lot about software, not AI particularly, although that might get a mention because it's been mentioned already. And the reason why I want to talk about software is that the company I work for, although we're known for shipping electronics, is actually in a software group. 5 other software companies, plus Meteor. And the software that we do makes the electronics that we do actually do something. The software, if you like, holds together all of those physical components that we said before. I'll run through very quickly. There's PDF software, which I'm not that involved with. There's RIP software, a bit more involved with. And then there's what we call the data path software, which takes the image that you want to print, all those ones and noughts, and fiddles with them before we give them to the print head in terms of electrical signals. And we fiddle with them not because we like ruining images, but quite the converse. We fiddle with them in order that what comes out the other end looks more like what the ones and noughts look like on the TV screen at the front end. And what I'm going to talk about today is this year, or anyway, some of the trends in what's going on in the way in which we fiddle, what kind of feedback loops are coming in, either between us and the print head, the small arrow, or looking at the outputs and feeding back in either pre-RIP or pre-data path. What I'm really referring to, if you like, is recalibrating the machine whilst it's in use or at points through its use. So we're making adjustments in order to optimize the printed output. There's the initial tuning and the initial setup, but then there's also, if you finish off the clicks here we go, is also setting up the machine so that it can correctly hide any errors in what it's doing and make the stuff sellable that comes out the other end of it. And I have a few slides you won't have seen. This next one you will have seen before, I think, which is the traditional drop watcher image. Here you see a couple of pulses and volts for those of you who haven't seen it before on the right-hand side. So that's the electrical signal that goes in, and there's a grayed out pulse, but there's another pulse before there. So we're using a couple of pulses to make 2 drops come out. And on the left-hand side, you can see the sort of traditional image where the ink comes out the top, goes down towards the bottom. And in this case, you can see this isn't a double. Some people, one of my colleagues asked me, is this an image of 2 strobes, as in the flash going off twice, so you're seeing the same drop twice? It's not that, actually. This is actually 2 drops. This is 1 flash, 2 drops. Sometimes people use the double strobe to get speed, because obviously the distance is moved between the 2 strobes. But anyway, enough about drop watches. This is the tool for that. This slide I don't think you would have ever seen before, because I don't think Meteor's ever shown it, and we only created it very recently. This is the latest we can do with optics. So this is a vastly magnified look at what's going on. And now we can start to see the satellites which you couldn't see on the previous image. So we can see very, very small satellites. In fact, we can see things which we didn't really know existed before. This is remarkable. We can actually zoom in this much. Look, the wavelength of light is only about 1/3 of a micron or something. But we can now see femtoliter drops coming out after the main pulse has happened. That's coming out from the echoes, from the wobbling of the meniscus, and the way in which, a bit like a swimming pool that's circular, there's a shake it and a wave hits the middle and shoots out the middle. And those sort of size drops are still coming out, they're flying into the air, they're a mist. Don't know where they go, but over 4 hours, over 8 hours, with 100,000 nozzles, it's all going to add up somehow, even femtoliters. So if you want to really know what's happening inside the waveform, I suspect the world's going to be moving up. This is they'll be moving up to this level of optics to be able to see what's happening at a very, very small scale to all of those unwanted bits of ink. And the problem with those unwanted bits of ink isn't that they pollute your image, because no one's going to notice. In fact, that's a good thing, because it will take it away and wash it away and disappears. The bad thing about it is if they don't pollute your image, if they in fact pollute your printhead, or maybe somehow work their way around and land on the electronics, and after a while form a bridge across things with voltages on or something like that. But if either of these build up and pollute your nozzle, get your jet pointing sideways, then you get some of those lovely images that Mark showed us earlier, where a jet's gone the wrong direction. And at that point, your image does start to look bad. And then you do have a problem, because at some point, someone's going to say, that's not sellable anymore. And then we're doing what we all started off not to do, which is produce junk. What we're about here with digital inkjet is producing sellable stuff all the time. The right amount of it, no waste of it, not too much of it, not too little, and being able to avoid all those issues that there exist with the non-digital printing and production techniques. So there's one little bit of new trend for you coming out this year, the future of drop watches. Nonetheless, even when you've done the best you can with this, you've still got the issue of what happens in real life when you have got a situation with 100,000 nozzles and they begin to start pointing in their own direction, one or two of them. So what's happening, I would like to say, is we're looking at, or the trend is moving towards automated analysis of what's gone on, an automated correction of what we see has gone on in order to make the product still sellable. So not necessarily as good as it was before, but still sellable. And also to try and work out how bad it's going so we can do a predictive maintenance, because that's not half so bad as predictive maintenance as having to stop something mid-production or mid-flow. So I will run through one or two images here. I think most of us have seen head alignment patterns. The only change here perhaps is the fact that companies like my own have put in software algorithms which automatically create them, irrespective of the geometry of your machine, and can automatically send images which are detected as different from normal images. So when the data path receives a test image, it knows it's a test image. We don't treat it like a normal image, so we actually let it through without any corrections. Normally, if you remember, I told you we fiddle with the data, but with a test image, you don't want to fiddle with the data. Ooh, I better speed up. Here's another one. On the left-hand side, we have a training pattern. So this is to help the cameras to work out what it's seeing. So the camera can self-learn, our software can self-learn from the camera what it's looking at. And on the right-hand side, you can see an example of a nozzle test pattern. This one's 77,000 nozzles. Again, all automatically created by software. And if we read any, or took an image of any single one of those little modules, we would learn something, because the little QR code tells us about what that little part is talking about. So it doesn't matter which one we read or which order. If we got any one of those, the software would automatically update the data path software that's producing that production to make a correction. What could we do for that? Well, most of the time we play around with mobile phones. So we just click, because it doesn't matter which order we're looking at, it doesn't matter which image we're looking at, whatever we click, that information is read, fed into the software corrects. And if there's a problem in that image, in those nozzles, it gets automatically updated and compensated for. You could replace that, of course, with a scanner if you really want more detail, or a line scan camera if you want it to be happening in line. But one of the choices is you don't have to see them all. You could see one part of those on every item that goes through, for example. So it takes 15 items or 100 items before you've looked at every nozzle. It doesn't really matter anymore. You don't have to print an entire pattern to work it out. The other area is electrical feedback. I think most of you know that Meteor has got a patent in this area, and we're working on how to listen to electrical signals that we are getting back from the print heads to tell us if they're blocked by, by stuff in the ink, whether they're misdirected, whether they're damped by a bubble, maybe some, or just simply things like it's part of them now broken because there's an electrical short or a decay or some kind. And I've mentioned here 4 different generations. We are working, if you like, our way through these in order. So we're developing electronics and software that will work when you eject ink into a waste tray. That will move on to looking at how to do that intermittently. So we're working our way through all the 77,000 nozzles bit by bit in between items as they go down, perhaps. Then we'll work on to how to do all that without ejecting any ink at all. So you can do it with the heads over the conveyor. And the last one, probably the hardest one to achieve, will be, can we do it whilst we're actually printing? So if there's a continuous web and we don't want to put anything down or have any delay time where it's not actually using that print head. So the tactical objectives, can we correct for missing nozzles? Well, yes. Intercolor, intracolor, we can put more ink down, we can halve the resolution effectively and put more ink down in many cases. Can we detect it on the fly or when we want to? Well, yes, with cameras, sure, many different types. Can we do it with electronics? No, but we're coming there. We're almost there, and we'll be there very soon. Can we do it, can we get rid of color banding? Well, yeah, but only with a line scan camera or some kind of flatbed scanner, because we need to control the optics. We don't want to pick up the differences in lighting and put that into the images as they go through. And can we do all of that with, with a variety of different imaging systems, some of which may already be on the machine? Yeah, in theory, we can. And we can set up training images to allow us to learn from what you actually get already. So the software will pick it up. And of course, head alignment. It's one of the easiest ones to do, but yes, we can do that. So you take a head out, put a new one in. You want to do that as quickly as you can. The software exists for that now. So all of that gives me my strategic objective of today's story. Can we get the head change around quicker? Yes. Can we predict when a head's about to need that happening? No, but we're getting there. I think we can. We've got some early evidence maybe we can. Can we extend the time? Yes, of course we can. We can find missing nozzles, correct them, and then delay the time when you need to stop production. Can we predict when we might need to pause? Again, harder, takes more evidence, but we've got the tools now to work on that. Could we extend a printhead life? Well, I don't know. We can certainly start to monitor and take big data on printhead performance. Can we compensate for changes? Yes, we can now. We can look at, if you've got the right camera system, we could look at how things changes with time, and you could put a new head in amongst an array of old heads and rebalance that out by looking at the data, as well as the normal things like changing voltage. So does all of that give you a better total cost of ownership? Well, I hope so. If you buy a machine and you can keep it running a lot more and interrupt its production a lot less, you can get a lot more value from it, and that will get a more eager acquisition of a digital printing system into that industry again. And of course that brings the benefits, less wastage of all the inks, media, screens and so on. We've got a bit more penetration, and everyone in this world, everyone in this room I should say, has a nice ending to their fairy tale story. So thank you very much.